For topic 2A, we are going to learn how to generate descriptive graphs and statistics using both Jamovi and Excel. The first thing that I want to do is introduce you to the data set we are going to be using to walk through this topic. So the posted data set is just this file in Jamovi called topic 2 data, and it's comprised of data from a survey of 196 stat students who took my course a few years ago, and I had them complete an online survey just to generate some data on a variety of behaviors and attitudes. Okay, so if you click through, you can see the variable names and the exact question wording, as well as the levels for each of the variables. Right, so for the second question here, for example, they were asked approximately how many hours on an average day do you spend on social media? I gave it the shorter variable name of just social media, and the levels or the choices were 1 to 2 hours, 3 to 4 hours, less than 1 hour, over 4 hours. And so here's another one, enjoy ACAD life. This question was on a scale from 1 to 10, where 1 is not at all and 10 is extremely. How much do you enjoy the academic life of university? And so this is it's been identified as a continuous integer variable, and there's no levels, right? Because that's what happens when the variable is identified as a continuous measure type. So the levels kind of disappear, but you can see in the description that this question was answered on a scale from 1 to 10. Now, if you were to go and change that to ordinal, then the levels that were selected by participants would also appear there. Okay? So anyhow, you can peruse this data set and just get a sense of all the variables that were in there. So we are going to use this data set to generate descriptive graphs and statistics. If we want to generate a basic descriptive graph in Jamovi, then we can do many things. So there's many options. And in fact, what I'm going to share with you here, it only really scratches the surface of the most basic things that are available. But we are going to start with making frequency tables. Okay, so frequency tables we learned about in lecture. They are just a simple way to get a sense of the most common values in the variable. So let's go ahead and make a frequency table for a few variables in this data set, right? So we're going to now get into the analysis tab. We're going to use the analysis tab, and we're going to go to analyses, and we're going to start with exploration. So for the first little while that we work on labs, we are going to hang out mostly in the exploration tab, exploration and then descriptives. Okay, so you'll see when you click on something in the analyses tab, this new window is going to appear. Okay, and so you'll still have the spreadsheet on the left. You can slide the other window open to make it larger, or that way to make it smaller, but you're going to have this new window right now. And I had some output there that I was working with before. I just deleted it, so we have a clean slate. So this is our output window, and we're going to go to exploration descriptives again, and here we go. Okay. So anytime that we have a window like this in Jamovi, you're going to see that all of the variables in the data set appear in this window here on the left. Okay, so it's literally just listing the variables in the same order that they appear on the spreadsheet, right? Gender is first, social media is second, enjoy ACAD life is third, etc. So when we want to have Jamovi give us some analyses, we are going to take variables from the list of variables window and put it into the variables window on the right. Okay, so we are going to move social media and Dutch into the variables window. Okay, so we already looked at what social media is, just so you're all on the same page. You know what Dutch is. So this question was just simply, are you of Dutch origin? And students answered either no or yes, and the variable name is Dutch. Okay, so if we want to get frequency tables for these two variables, okay, we put them into the window and we click off frequency table. Okay. Something that I want to point out here is that Jamovi is only going to give you frequency tables for the type of variables that are kind of pictured in these little icons beside the frequency tables. So it's going to give you frequency tables only for nominal variables or ordinal variables. Right? So if you want to get a frequency table, you have to make sure that the pictures beside the variables in the variables window match the pictures beside what you're asking it to generate. Okay. So you can see that by doing this, it has generated a frequency table for social media, see frequencies of social media and frequencies of Dutch. Right? Whereas if I put a continuous variable into the variables window, it doesn't give me a frequency table, right? Because it just doesn't do it with that kind of data. Okay. All right, so before we go into the frequency table, I just want to show you one more thing about working with this system in Jamovi, where you have the list of all variables on the left-hand side, and you move them into the variables window on the right-hand side. If you are looking for a specific variable in this list, especially if you have a long list, you can actually click on this little search function here and search for a variable. Okay, so one of the variables I know I'm going to ask you to do something with later, it has COVID in the title. So if I'm looking for the COVID variable, I can just type COVID and I can see, oh, there's my COVID variables. Okay, so that can be a handy tool when you are looking for one specific variable in a large data set or a data set with lots of variables. Okay, so let's take a peek at these frequency tables. Pretty similar to what you saw in lecture. We did this where you have the values down the side here. Okay, so each value for this variable is here. The count for each value, the percentage for that value, and Jamovi also gives you this additional feature that's called cumulative percentage. Okay, so actually now I want to pause and I want you to take a look at this table for the variable social media. And there's actually something that should be fixed that I should have fixed before I even put that variable into the window to have it make a frequency table. So take a second and see if you can figure out what that is. Hopefully you picked up on the fact that the levels are actually out of quantitative order, right? So the first level here listed in the frequency table should of course be the lowest value, right? So this is an ordinal variable, meaning there is an order to the response categories, but they are kind of out of order, right? And this is because less than 1 hour, that actually it's less than 1 to 2 hours. So that should come before 1 to 2 hours. So you can actually just go in to the spreadsheet, go back to this variable, and I'm going to move this. Remember, we learned how to move these levels around last class. I'm going to move that to the front. Now it's in quantitative, or the levels are in quantitative order, and Jamovi will automatically update that, which is nice. Okay. Yeah, but other than that, that's just your basic frequency table. Pretty simple, with the added nice feature of that we didn't do in the text and lecture of the cumulative percentage. And so now that we have it in proper order, now we can interpret the cumulative percentage, and it's just adding up the individual percentages of the totals. And it's just nice because, for example, you could pick one value, so say 1 to 2 hours, look at the cumulative percentage, and you could say, well, 66.3% of the sample are on social media are on social media for less than 2 hours, okay? Because it's combined. 66.3% is the combined percent that reported less than 1 hour or 1 to 2 hours. I think the only other thing to point out is just to note that the word Jamovi uses for the number of participants that selected a particular value is counts. And in lecture and in the textbook, instead of counts, it uses the term frequency. Okay, but it's exactly the same thing. And then for the Dutch variable, it's nominal, so it doesn't matter whether it's no, yes, or yes, no. Order of categories does not matter in a nominal variable. And so you can just take a look at this and see It's about a 50-50 split. 48% are not Dutch and about 52% are Dutch. All right, so that's a table. Now let's focus on making more of a graph or a picture. And recall that you can essentially put the frequencies into a graph form. We learned how to do that in lecture with the histogram. Okay, so we are going to now create bar plots, which does exactly the same thing as a histogram. It just shows you a picture of the frequencies. All right, so if you click on plots, like your software might show up a little bit differently than mine. Plots, you may have to click on it in order to see those boxes appear. So if you do, then just click on the plots, and we are going to ask for a bar plot. So if we just click bar plots, you will see that Jamovi creates just it's a graph, a picture of the frequency distribution. So along the x-axis is the values of the variable, and then the bar, or the height of the bar, represents how many respondents selected that particular value. So you can see, so for less than 1 hour, right, which is here, there's 31 people who selected that value, and that just corresponds with the height of the bar there. Something to point out here, you can see that we've created this bar graph for social media, but the values run into each other, and which doesn't look nice. I don't like how that looks. And so we can shorten the value labels in the variable information window just to give us a cleaner look here. So we can go into data, go into social media, and we're just going to shorten these. So we're going to go less than 1 hour, and I'm going to actually make that HR instead of hour. And same thing for those. And then we'll do greater than 4 hours. So again, it's going to automatically update, and you can just see that this is a much cleaner and easier to read x-axis here. So these charts are fine when you are just trying to get a sense of the most and least common values, the shape of the distribution, but I don't love them for their presentation quality. They're not easily editable. You can't change the color, and they're not the best graph for if you're doing a presentation. So what I want to teach you quickly is how to create a bar graph or a bar plot in Excel. So everyone go ahead and get Excel opened up. All right, in Excel, the first thing that you're going to do is copy and paste the frequency table that you created from Jamovi into Excel. So for this, you want to kind of hover your cursor over, let's use the social media frequency table. So hover it over and then right click. Okay, and then it's going to automatically highlight table, and you're just going to click copy. Then you're going to put your cursor into Excel, a cell on Excel, any cell. And then you are going to, you can right click and just click paste special. Or you can press Control V and it will do the same thing. So however you like to paste it in there. It's a little bit annoying because it kind of leaves blank spaces in between the columns. And so you need to delete a few things. You're going to essentially delete everything except the value names and the counts. Okay, so just the values and the counts is what you need. You're going to delete everything else. And so to delete a column, right, if you're not sure about how to do this, you just highlight a column, right click, and then click delete. Okay, so the information in Excel the information that Excel needs to create your bar graph is just these two columns here, right? That's all it needs. And so all you're going to do is highlight what you need, which is the value names and the counts. And you are going to go to Insert, and you're going to go to Recommended Charts. When you click this window will pop up that allows you to kind of peruse the different kinds of charts that Excel can create. Generally, it's pretty good at selecting the right kind of chart for the data that you have selected. And in this case, it's selected something called a clustered column chart, which is just what Excel calls this kind of bar graph we're making. So you're going to leave it on clustered column and click OK. So now you have your chart, and I want to show you how you can edit your chart and how you can do a lot more with a chart in Excel that you can in Jamovi. So if you click on your chart, then you'll see these 3 buttons pop up. Now I should say this, so this is a PC. In Macs, it might be a little different. You might find these buttons on the top, on one of the top ribbons in Excel. So you'll just have to play around with that. But you're looking for these icons, and this one in particular. So this is Chart Elements. So Chart Elements is the tool in Excel that really allows you to edit your graphs. So say I want to create axis titles. Okay, so that means that if I want a title for my X and Y, I can click on that there, and then I can just go in and edit it. Okay, so I have, something like hours of social media use. And then I could make something like frequencies or counts, my title for the Y-axis. And so you can edit that to whatever you want. You could add a title for your chart if you want. I'm actually gonna show you in a couple of minutes that typically for an APA style chart, you would delete the default title that's embedded in the Excel graph, and you're gonna make your own title in a document, but I'll show you how to do that later. But in any case, if you're doing it for something that doesn't require APA style like we do in this class, then you could keep and edit that chart title to whatever you want it. So see when I could click back on chart title and it would appear again and I could edit it, but I'm just gonna get rid of it for now. You can also add data labels, which is nice sometimes. So if you add data labels, it will just put the actual number for each count in the table, which again, it's kind of nice to have because then you can tell exactly what the count is for each value. Whereas if you don't have the data labels on, then you're kind of guesstimating. So I'm gonna leave the data labels on for now. Another thing which is a nice feature is that you can change the colors of your graphs, which again, if you're trying to do like an aesthetic presentation, you have a theme, you can change your graphs to work with whatever colors that you are using. So you can just play a little bit there on your own laptop with changing the color to something that you like. And you can play with the styles as well, right, to suit your style. All right, so pie charts are another nice feature that Excel allows you to create that Jamovi doesn't. Pie charts are great for presenting simple kind of percentages. And so let's practice making a pie chart with this data that we have here. Again, all we need is the value names and the counts. We are going to go to insert, and this time we're not going to go to recommended charts, but we know that we want a specific kind of chart. We're getting a pie chart. So you're going to click on pie chart and a 2D pie chart. So again, I'm going to get rid of the chart title. You could play with, where you wanted these values to be, and whether you wanted data labels there. So again, because something that pie charts are particularly useful for is just to give you a sense of the percentage, you might want for the data labels, not the raw counts, right? So not like 31, 99, 52, 14, but you might want the percentages, right? So that's actually very easy to do using a pie chart, and that's generally how I like to see pie charts. And in order to do this, you kind of have to click right on the pie area of the chart. So the whole pie is highlighted, right click. And then when you right click, this window will pop up, go to Format Data Labels, and it's just the value as the data label. But I want the percentage, and I'm going to click off value and see now it shows me percentages, right? So again, I can see, so 16% of people selected less than 1 hour, 50% selected between 1 and 2 hours, etc. Okay, so now we've made some charts, right? We have some in Jamovi, we have some in Excel, and I want to show you how, if you were grabbing this figure, one of these figures, to insert into a document, specifically an APA style document, that's the style that we use in the social sciences. I want to show you how you would do that and kind of present a figure within a document in APA style. All right, so say you have a Word document and you're writing a report on a variable and you want to insert a figure. Okay, so I already told you that we need to delete the title that Excel would provide in the body of this graph that it creates. So that's good. We don't need to actually go and delete that because we already did. You are gonna copy this graph into your Word document. And just a quick note about that. So for Excel and Jamovi, you can copy and paste output in one of two ways. Do the way that you're clicking on something and then hitting right click and copy. You can then go to your document and go paste, and it looks like that. You can also do a screen grab, which is often easier. That's what I end up doing. Sometimes it doesn't matter, but in many instances, when you're trying to copy and paste something, sometimes it can just look a little weird when you just do like the Control C, Control V. But a fail-safe way to do a copy and paste is to do a screen grab. So your screen grab, as most of you probably know how to do, in Windows, you would be clicking, Windows Shift S, and then you can just grab the part of the screen that you want to put into another document. Okay, so once you've done that, then you just go to the document and hit paste, and it puts your screen grab right in there. Okay, so now you've got your chart in your document, and in APA style, you need to make a title for that figure, and it's done in a very specific way. So for the first figure in a document, so there's always 2 lines of a title. The first line, you're going to give it a number, so figure 1, and then the second line is always in italics, and it's some kind of descriptive title, right? So for a bar chart, like percentages of social media use frequency, something like that. Okay. And the descriptive part is not bolded. Okay, so that is always what the title for an APA style figure or table is going to look like. And say for this next one, say this is the second figure in a document. That would be figure 2. It's going to be bolded. And then this is the social media variable. You can say, again, frequencies of social media use. And those should be capitals. And not bolded. There. All right, at this point, I think we're ready to move on to the next section, which is generating descriptive graphs for continuous variables and then ordinal variables with integer data type. Okay, so for this, we are going to go to the countries variable. Let's look at countries. That's kind of about halfway through the data set. This is a question that asks participants, how many countries have you traveled to? And this was presumably just an open-ended question. Participants wrote in the number of countries they've traveled to. So it's been identified as a continuous measure type with integer data type because there's no decimals, right? You can't go to 10.5 countries. So it's integer. So we're going to go and get some descriptive tables and graphs for this type of variable. So I want to point out one thing just in terms of like navigating Jamovi and where you put your cursor and where you go. Okay, so if you want to just keep adding variables to an analysis that you've already been doing, like we did right there, social media and Dutch. So we could just add countries there and then go and ask for it to give you the new things that we're going to do. That's fine. But I often kind of like to separate out the sections of analysis that I'm doing. Like I want a kind of a brand new fresh start where I'm going to be looking at these new variables, and I don't want the information from social media and Dutch to be there, right? I just want to have a fresh start, but I want to keep what I've already done. So in order to do this, so to get a fresh descriptives window with these new variables we're going to analyze, while still keeping what we did with social media and Dutch, okay, here's what you do. So you have to go back into data, then go to analyses, exploration, and descriptives, and see now it gives you that fresh window to start with. So it's going to keep what I did above, but let me start fresh there. So what I'm going to see here is only for these new variables that I'm looking at. So I'm going to put countries here in my variables window from the list. Okay. The next variable that we're going to put into our variables window is this variable here at the end of the data set. And I want to just talk to you a little bit about what this variable is. So something that we are going to learn how to do next week in lab is to create new variables in a data set based on some combination of existing variables. Okay, so in this data set, you can look and see that there's 5 questions that all ask about kind of self-esteem stuff, right? You know, I'm a person of worth on an equal basis with others from 1 to 4. I have a number of good qualities, etc. These are all questions that kind of tap how good people are feeling about themselves, right? Something that we do a lot of the time in the social science is we combine multiple questions assessing the same construct into an average of that construct, okay? So we could take each person's average for the 5 self-esteem questions, right? And if I took, say, the average of person 190 of their 5 answers to those 5 self-esteem questions, then we could compute that. And for person 190, we have an average self-esteem score that kind of reflects overall how they feel about themselves based on these 5 questions. So that's what I've done. That's what I've created in this last column here. It's the average self-esteem. And again, we'll learn how to do this. It's, as you can see, it's not rocket scientist. I told Jamovi to compute the mean of those 5 self-esteem questions in the data set. Okay. So, you know, person 1, their average for the 5 self-esteem questions, right? So 3 plus 4 plus 3 plus 3 plus 3 divided by 5, 3.2. So person 1 has an average self-esteem of 3.2 based on those 5 questions. Okay. So we have this average self-esteem variable, and we are going to put it into the variables window and get some information about that. For these variables, we are going to get Jamovi to produce a histogram and a box plot. Again, these are just slightly different ways of looking at the distributions of variables. It's nice to get a density plot with the histogram because it kind of gives you a drawing or a curve that represents the shape of the distribution. So a histogram is what we're going to use rather than a bar plot for these continuously distributed variables, right? The variables that have the little ruler sign beside them. And it looks a little different than a bar plot, notably in the values that Jamovi gives along the x-axis, okay? So these labels are automatically generated by Jamovi, and sometimes the values are different from kind of what the actual values are on the scale, right? So for countries, like it's got 2.5 and 7.5 along the x-axis, but of course there's no actual value of 2.5. People aren't reporting going to 2.5 countries. So the x-axis values doesn't really matter in a histogram. What you're really looking at is a sense of the shape, right? Like if you look at this shape for the countries variable, you can see that, you know, it's got a bit of a skew, right? A bit of a positive skew with scores piled up on the low end. People aren't, you know, massive world travelers in this sample. And that's really the only information that you're looking to get from a histogram. So don't pay attention to the x-axis values label so much, and just get a sense of the overall shape. And here you can see for average self-esteem, same kind of thing. Get a sense that, you know, that there's the low end of the graph and the high end of the graph. The shape looks like, you know, it looks like most people are doing pretty well in terms of self-esteem, right? Most people are scoring at 3 or above. So this doesn't seem to be a sample that's having particular struggles with self-esteem. It's more skewed to the high end of the response scale. Right? So histograms just give you a general idea of the shape. Box plots are something. Oh, before I move on to box plots, I want to say one more thing about using histograms to identify the skew. Sometimes, not so much with these variables, but with other variables, it can be tricky to look at the histogram and say for sure, yes, this is negatively skewed, or this is positively skewed, or this is very symmetric. And something that can be handy to look at in conjunction with the histogram is the skewness statistic, okay? So if you go to statistics and go to distribution and check off skewness, okay, and then you can see some descriptives pop up here, and we're gonna get to all of these other ones in a minute, but skewness, okay, so for the countries variable, the skewness is 0.875, and average self-esteem, the skewness is negative 0.585. So it gives you a number for skewness that is actually very easy to interpret. A value at or very close to 0 indicates no skewness at all, like a perfectly symmetrical distribution. As skewness goes higher, right? So positive values, that means a positive skew is present. So, you know, for countries, 0.875, it is visible that it's a visible positive skew. And then self-esteem, it's skewed, but in the other way, right? So there's a negative positive skew, a negative skew. The scores are piled up more towards the top of the distribution, right? So that's a negative skew. And again, just use the skewness statistics in conjunction with the histogram to confirm the direction of the skew. Now on to box plots. All right, if you're following along with the handout, you can see box plots. They're just giving another visual depiction of the overall distribution of a continuous variable. And it captures several aspects of a distribution all in one. So first of all, it gives you the median. All right, the median is the thick line here, okay, in the box. That's the median, so it's also the 50th percentile of scores, right? The 25th percentile is the bottom of the box, and the 75th percentile is the top of the box. All right, so let's interpret this using, I'm going to bring the lab booklet back in here, and I'm going to use this simpler variable to first walk through what a box plot tells you. Okay, imagine a variable that is just height, right? So say 100 people listed their height in inches. Okay, so height, you can see inches range from 50 to a little over 70. And if the box plot looks like this, okay, here's how we would interpret. So let's start with the line in the box, which is the median, 50th percentile of scores. To find the median, you're going to follow this line to where it would cross on the y-axis. Okay, so if I were to follow this line over, so just follow my cursor, it crosses the y-axis at about, 63 inches, say. Okay, so that means the median is 63 inches, and that tells us that 50% of people in the distribution are shorter than 63 inches. The bottom of the box here is the 25th percentile. Okay, so we're going to follow the bottom of the box, that line, over to where it crosses on Y, and it's about like 57 inches, right? This is 55, so 56, 57 inches, and that tells us that 25% of people in the distribution are shorter than 57 inches. Similarly, the 75th percentile, right, we can take that and follow the line to where it crosses on Y. It's about 64. So that tells us that 75% of people in the distribution are shorter than 64 inches, right? And box plots also have these kind of whiskers on them, for lack of a better word. In some textbooks, they call them box and whisker plots. And basically, you only need to remember that any observation beyond the whiskers are considered potential outliers, right? Scores that are kind of abnormally far away from most of the scores in the distribution. So if a researcher is looking at this graph and there's 2 dots, right, that fall outside of the whiskers, that means that these are 2 outliers, like people who are kind of abnormally tall in the context of the distribution. And sometimes that can be helpful to researchers in the sense of, well, maybe I need to go and look at these numbers, and they might just be 2 really tall people, but maybe, these are people who they weren't paying attention when they were filling out the survey. Maybe that was an error, and you just might want to go and take a look at those 2 cases to see if, they're real, or if you might want to delete them from the data set. So it's good for researchers to be alerted of the presence of outliers, and box and whiskers plot give a very nice visual depiction for finding these outliers. Actually, this is a newer version of Jamovi than the one that we were just looking at with the heights. I think I created that one with an older version of Jamovi, but in the newer version, it actually so here's some outliers for average self-esteem, and it tells you what number, like what case, what row, really, it tells you what row that outlier is in. Okay, so for self-esteem, we've got a person 152, or row 152 and row 31 are individuals who got abnormally low self-esteem scores. And so we could go and look at person 31, row 31, and you can see there that's their average self-esteem score. It's very low in the context of the distribution. So, as a researcher, you might want to go and check out person 31 as well as the other low outlier there. All right, now that you know how to look at and interpret outliers, here's something that you can do with the countries variable so I want you to look at the countries variable, the box plot, and fill in these blanks. Okay, and that will give you a little bit of a test for how to interpret, or practice, not test, a little bit more practice for how to interpret that information. And it should be pretty easy, but if you are unclear or uncertain, just send me an email or talk to me in class. All right, the last part of this video is going to cover generating basic descriptive statistics. So this is actually very straightforward. If we want to get things like the mean, median, standard deviation, that kind of information from Jamovi, we are simply adding variables into the window. That's what we're going to stick with. countries and average self-esteem. So again, if we wanted a new window, a fresh start, we go back into data analyses, exploration, descriptives. So it's giving us this fresh start. We're going to enter the same variables here that we've been working with, countries and average self-esteem. Okay. And we are just going to check off, so this is the statistics. We're going to make sure that statistics is clicked, and then it gives us all kinds of options. Right, so we're going to get N, missing, say the mean, median, standard deviation. I'm going to check off minimum and maximum, skewness and kurtosis. There's lots of options, but we'll kind of stick with those. Now, something that I want to point out is, so when you check off all of these things, you can see that it generates information for you, right? And it just populates as you check it off. So if I was to click mode, you can see that mode now appears for each variable, right? Because I've just got countries and self-esteem. So it's giving me all of these statistics for just the countries and the self-esteem variable, right? If I added variables, it would just add them that way. Now you have an option in terms of how this information is presented. If you go to the descriptives window, the default, it chooses to present variables across columns, but you could also select variables across rows, which just presents the same information just in a slightly different way. So I personally kind of prefer it like this, but you might prefer it the other way. So just wanted to give you that option. Okay. In terms of interpretation, you already know how to interpret this information, like the mean and standard deviation and the median. We talked about interpreting the skewness statistic. Actually, we don't really need kurtosis here. We're just gonna stick with skewness. So you know how to interpret these. The only thing I want to mention that you might be a little unclear on is missing. So what does missing tell you, right? So it tells you for each variable whether there was anyone from the overall data set who did not have a response on that particular variable. Okay, so remember the total N, so that there's total of 196 people, 196 rows in this survey. Okay, for the variable countries, every single person gave an answer to that question. So that means the total N for the countries variable is 196, and there are 0 cases missing. Okay? For average self-esteem, out of the 196, there were only 194 who have a response for who have a score for average self-esteem. So there were some missing cases, specifically 2. So there are 2 participants who do not have a score, who are missing a score for average self-esteem because they didn't fill out at least one of the questions that comprise the self-esteem average. So the total N for average self-esteem is 194 and 2 are missing. And so then of course the mean and standard deviation, etc., that's all calculated based on the N, the total N that's listed, right? So 194 for self-esteem, 196 for countries. Final thing to point out is that if you add variables that are not numeric into the window, you can do that, but you'll see they will not generate statistics, obviously, right? Because Dutch and also social media, those are non-numeric variables, and so it will give you the N and the missing for each of these non-numeric variables, but of course it's not going to compute a mean, standard deviation, etc. Okay, and that's all for this one.